Here we have our BeagleBone PCB in the PADS Professional Layout tool. From here, all I have to do is start the DRC client from the Integrated Analysis Control window. Now that my project has been loaded into DRC, I can see that the format is very similar to that of PADS Professional Layout. Over on the left, I've got project data, all of which has been automatically brought over from my design. I also have analysis setup and rules and results. The rules are all broken down into different categories to help you determine which ones are the most important for your design. Before running my rules, I'm going to create a custom object list to include only the nets that I'm interested in. In this case, it's going to be my GPIO nets. Down in the property window, all I have to do is specify an object list of type electrical net, set it to auto, and then choose a condition. In this case, I know that all my GPIO nets follow a standard naming convention, so I'm going to choose name starts with GPIO. Just like that, all of my GPIO nets are added to this list. With the increased complexity and density of today's PCB designs, finding and reviewing all instances of a net crossing a split plane is a grueling manual process. Additionally, simulation tools do not typically check for those occurrences. So here's the problem. When a high-speed net crosses a split plane, it can create an impedance discontinuity on the signal trace, possibly leading to unwanted reflections, radiation, and crosstalk. By running the nets crossing gaps rule, you're easily able to pinpoint when and where these discontinuities may appear. DRC has a built-in description of its rules along with prerequisites and a number of customizable parameters. In my case, I know that I want to run this rule on my previously defined GPIO object list. In order to do that, all I have to do is specify that object list in the property window, as you can see here. Then, I just right-click on my net crossing gaps rule, and then click execute. Just like that, in a matter of seconds, we can see that I have 28 violations just on those nets. If I want to further explore these violations, I click on the Spreadsheet tab and then Results. Here we can see each instance of this violation, which I can click on, and it'll jump to and highlight on my design where that violation occurs. When I hover my mouse over the highlighted net in the layout window, I can see more information. In this case, my net crosses from the 5-volt reference plane over to one of my DDR reference planes. Going back to my PADSPro layout tool, we can see that the violation data from the rule that I just ran has automatically been brought over from the DRC client. If I click on my hazards view, I can see all instances of those violations in greater detail. If I click on a hazard, it'll zoom directly to that location on my design. This way, I can easily make changes to my layout without having to manually cross-reference between tools. If I determine that this violation needs to be fixed, I can make the necessary changes, rerun my DRC rule, and of course, that violation will no longer appear. I can also run rules directly from my layout window using analysis control. This is especially useful when rerunning rules to make sure that the violations are cleared once I've made changes to my design. In this case, I'm going to execute a separate IC over splits rule. This will check whether integrated circuit components have a proper reference beneath them. If an IC doesn't have an integrated reference plane in its package and is not properly referenced beneath, it can lead to common mode radiation. Here we see that there are 16 instances of ICs without designated reference planes. Once again, I click on a specific violation and the tool will jump to that location on my design.